This is a discussion on the material in section 3.4. So in the last unit 3.3, we learned some very useful rules. One, the most important, I think, is the power rule, but that multiplying, taking the derivative of a constant times a function is a constant times a derivative, or that the derivative of the sum is the sum of the derivatives, which is, not necessarily a given in this world, that things are linear like that. And then we looked at a bunch of examples, and we saw that some of the problems that were difficult, like in sections 3.1 and 3.2, like 1 over the square root of x, turned out with these rules, turned out to be quite easy. And then also just, finding where the function, the derivative is 0, and finding tangent lines. So let's just learn a few more rules. So here's another important rule, and that's the product rule. And so now we're taking the derivative of a product, but it's not true. So we definitely don't want to fall into this trap. The derivative of a product is not equal to the product of the derivative, right? So let's say we're taking the derivative of f of x times g of x. Well, it turns out the answer is right down here. It's the derivative of g of x times f prime of x plus f times g prime of x. It's right here. And then here's actually a proof, which, this is not a proof course. This proof isn't so bad. And so this is kind of fun right here. Do you see, I don't know if you can see the, here's where we have, okay, there's the difference quotient right there. We want to take the derivative of f of x and g of x. So the function of is f of x times g of x. So it's f of x plus h times g of x plus h minus f of x times g of x over h. And then to actually get the to get the answer, to get the rule that we're adding 0. So that's a trick that mathematicians do a lot. And so you can see there, like in the stuff that's in the expressions in the blue fonts, we're going to subtract off minus f of x times g of x plus h, and then we add f of x times g of x plus h. So we're just adding 0, but we added in this kind of, who would ever think of it? So, some kind of clever came up with that. And then look at, now we're going to break the derivative up into two parts. Okay, so half of the blue goes with the f of x plus h times g of x plus h, and the other half of the blue just goes with f of x and g of x. And so on the left side here, you have f of x times g of x minus f of x plus h times g of x plus h minus f of x times g of x plus h. So you just factor out the g of x plus h. And then the right half, what you do is you have f of x times g of x plus h minus f of x times g of x. So you factor out the f of x, and now we're going to take the limit as h goes to 0, or the limit is g of x plus h goes to 0 is just g of x, and then the limit as h goes to 0 of f of x plus h minus f of x over h, that's f prime of x. And here it's the same thing. The limit as h goes to 0 of f of x, that's just f of x, and then the limit of g of x plus h minus g of x over h is g prime of x. Okay, so it turns out when you take we have that product, just one, it's just one, there's no additions or anything. It's just f of x times g of x. You end up with a sum. So if we kind of like it's growing, the function's growing. Okay, so it gets a little more complicated. So definitely, students, definitely practice these. We don't want it, whatever, we do not want to fall into the trap of saying the derivative of f of x times g of x is the derivative of f times the derivative of g, because that means you're going to get the problem totally wrong. Both, and plus it's frustrating. You're spending a lot of time trying to solve these problems, and you can't get to the correct answer because you're not taking the correct derivative. And then there's the famous quotient rule, which is even a little bit more complicated. And you could almost, to motivate, you could actually say that's, and I'm circling it right here, the derivative of f of x divided by g of x. And we're assuming that g of x it has to be taken in an interval where g of x is not equal to 0. Well, you could say that's g of x to the -1 first, and you could use the product rule if you want. So we're actually not going to prove it, but it turns out, and once again, you just keep it written down, so or handy when you're actually working on these problems in 3.4. It's the derivative of the derivative of the quotient f divided by g is g times f prime of x minus f of x times g prime of x the whole thing divided by g of x squared. And so it's kind of a mess, but again, it's certainly better than if we have to go back to the original definition of the derivative. In this case, it's almost impossible to do. So now let's look at some, one, we saw this before. We had the derivative of, okay, it's actually a polynomial. You have 3x squared minus 5 times 2x plus 7. And so 3x squared plus 5 minus 5 will be one part of the product, and 2x plus 7 will be the other one. So it's f times g prime of x. So it's 3x squared minus 5, and the derivative of 2x plus 7 is 2, right? And then it's going to be g times the derivative of f. So it's 2x plus 7, and the derivative of 3x squared minus 5 is 6x. And then you just kind of expand and you simplify, and I think you can do that. You'll get 18x squared plus 42x minus 10. And then our technique in the earlier unit 3.3, we said, well, all we had was we knew how to take the derivative of a sum, so we actually took the product and then took the derivative. Yeah, so if you find the product of y, you get 6x cubed minus 21x squared minus 10x minus 35. And then if you take the derivative of each term, yeah, you better get the same answer. Just because you use a different approach, your method of solution shouldn't affect the solution. There's one answer. So if you're trying to get two different ways and you're getting two different answers, something is wrong. So hopefully, though, you definitely want to get this. If you're using two different ways, you're trying a problem in two different ways, the answer has to be the same. Okay. So now, look at this. Example 2. Now, our first chance to use the quotient rule. And so let's just remind yourself what that is. It's so f over g, it's g times f prime of x, and now it's a difference, f minus g prime of x, and then the denominator is, we square the denominator. Okay, so in this case, our f is 5, I'm looking at this problem right here, our f is 5x plus 7, and the denominator g is 3x minus 4. So let's look at the derivative, and now it's not so, if we had to do like that p of x, 5x plus 7 divided by 3x minus 4, well, to go directly to using the definition would be difficult. We could actually use, divide 5x plus 7 divided by 3x minus 4. That's what we'd have to do. But still, it still would be, a lot of work. But now we can just go direct with our friend, the quotient rule, we can just go directly to the answer. So the derivative of f is 5, and the derivative of g is 3. So it's g times the derivative of f, and the derivative of f is 5, and then it's f times the derivative of g is 3, and then we square, and the denominator is g squared. Okay, so you expand and simplify the numerator, right? You get 15x minus 20, and then don't forget to distribute that minus. You get minus 15x minus 21 over 3x minus 4 squared. And then again, keep simplifying as much as possible. Yeah, the 15x's cancel, and minus 20 minus 21 is minus 41. So the original function was 5x plus 7 divided by 3x minus 4. And then the derivative is minus 41 over 3x minus 4 squared. So really, it wasn't a lot of algebra to get the answer, and it certainly is faster than appealing to the definition of the limit. So okay, so then so now there's one that's actually harder, and let's look at example 3 here. And so, wow, look at that function there. 4 plus the square root of t in the numerator, and denominator 5t minus the square root of t plus 7. Well, section 3.1 or 3.2, we were just, oh no, well, let's just give up. But now, nothing is going to stop us now. Okay, so our f is 4 plus the square root of t, and our g is 5t minus the square root of t plus 7. So remember, it's g times f prime, and then it's minus f times g prime, the whole thing divided by g squared. So, okay, so then the numerator is, so let's look at the numerator. So our denominator, right, it's g, so our g is 5t minus the square root of t plus 7. And then the derivative of the numerator is 1/2 t. So the derivative of 4 is 0. And remember, t is, we have to write it as t to the 1/2. So you get 1/2 t to the negative 1/2. Okay, so that's the first part. That's g times f prime. And now remember, it's f, 4 plus the square root of t. And now we take the derivative of 5t minus the square root of t plus 7. And so we get, again, the t in the denominator has to be written as t to the negative 1/2. And when you take the derivative, like the derivative of 5t is 5, the derivative of the square root of t is 1/2 t to the 1/2. And then you just square the denominator, 5t minus square root of t plus 7. Oh my God. So we're not going to expand that, are we? Okay, so now, but let's do our best to simplify the numerator. And we have to be kind of good in our algebra. So we just take, but again, we just use the law of the exponent. So 5t times, so we distribute this 1/2 t to the negative 1/2. So 5t times 1/2 t to the negative 1/2. So it's t to the first plus times t to the negative 1/2. You add the exponents, you get t to the positive 1/2. And once again, square root of t, which is t to the 1/2 times t to the negative 1/2. Add the exponents, you're just going to get 1/2, and you get 7 times t to the negative 1/2. And I'll let you distribute 4 plus square root of t times 5 minus 1/2 t to the negative 1/2. I think you could do it. Plus, mine just kind of rambling probably isn't exactly helping. And so then when you get the final answer, okay, so we want to simplify. See how we have in the numerator, we have 2's like 5 over 2 and 11 over 2. And we also have this t to the negative 1/2. So let's just clear that. So we're going to multiply the numerator and the denominator by 2 times t to the 1/2. And that way all the exponents in the numerator are positive. And then we won't have any fraction. We won't have all the denominators in the numerator will be 1. And it just kind of makes it a little bit easier to read. We're not going to expand 5t, the denominator 5t minus the square root of t plus 7, like there's 3 terms squared. We're just going to leave it like that. So, okay, so students, let's just look at this example 3 one more time. Let's just look at the original function. The numerator is 4 plus the square root of t, and the denominator is 5t minus the square root of t plus 7. And look how fast we actually found. I mean, if you make a mistake in the algebra, it's not so fast. You make a mistake in the derivative, but look how look how relatively fast we found the answer. And whereas like before this rule here, this quotient rule, there's no way we would have found that the derivative of g is actually minus 5t plus 11 minus 40 squared root of t divided by 2 squared root of t and times the quantity 5t minus the square root of t plus 7 squared. Okay, so again, let's just quickly review the quotient rule. Remember, derivative of f of x over g of x. G times f prime minus f times g prime over g of x squared. So it's a big mess. I mean, the derivative rule, the quotient rule sounds, it's not maybe, we don't look and go, oh, wow, I love that. But look how much it makes life easy for us. Oh, now how about this? The function, example 4, 8 over x squared plus 4. And of course, that has a horizontal asymptote, right? As x goes to positive or negative infinity, 1 over x squared plus 4 goes to 0. And of course, the function's always, the y coordinate's always positive. When x is 0, you get 2, and that's the highest point. So the function's always above the x-axis. And then as x gets bigger and bigger and bigger, the curve gets closer to the line y equals 0. Okay, so and so I think some of us, let's just, again, now to take the derivative, so we'll use the quotient rule. So 8 will be, then f will be 8. And so f prime is 0, and the denominator is x squared plus 4. So it's x squared plus 4 times the derivative of 8, which is 0, and then minus 8 times the derivative of x squared plus 4, which is 2x. And the whole thing is divided by x squared plus 4 quantity squared. So you get minus 16x over x squared plus 4 squared. So that really, that's pretty fast to take that derivative. And now what does it say? We want to get the equation of the tangent line when x is 1. So we know that f of 1 is 8/5, right? Right? You plug in, right here, you plug in 1, you get 8 over 1 squared plus 4. So the curve goes through the point 1, 8/5. The derivative turns out to be negative 16x over x squared plus 4 quantity squared. So f prime of 1 is, you just plug in x equal 1, you get minus 16 all over 5 squared over minus 16 25ths. And so the tangent line is 8 minus y minus 8/5 equals minus 16 25ths x minus 1. And you can isolate y if you want. And then, so another kind of fun problem is, Okay, so find where the curve has a horizontal tangent line. Well, you can actually just look at it and see that, it's where the line's changing direction. As you approach zero from the left, the curve goes up. The derivative is positive, right? When x is negative, when x negative 16 times a negative is a positive. So the derivative is positive as x approaches, and we approach zero from the left. If we approach zero from the right, the derivative starts becoming negative. So we're going from positive. At some point, we go from positive to negative. We're going to get zero if it's a continuous function. Find where the curve has a horizontal tangent line. So just solve f prime of x is equal to 0. So let's just solve minus, right? Original function is 8 over x squared plus 4. The derivative is minus 16x over x squared plus 4 quantities squared. Now just find where the derivative is 0, solve that equation, and basically you end up solving, the denominator can never be 0, right? Because it's x squared plus 4 squared, when x is, the smallest it can get is 16. And so just solve minus 16x equals 0, or x equals 0. So so it's 0, comma 2. The tangent line is just this flat line. I think that's all. Then here's kind of another kind of vaguely fun problem here. So maybe you have this function p, you have two functions in p and r, and p prime and r prime, and you have this table, and their values at 1, 3, and 5. So the value of p and r and p prime and r prime at 1, 3, and 5. And now it's a little hard to see. Let's see if I can make this a little bit bigger. Of course I can. Let me try this way. You can see, let me just do it one more time. You can see here, we want to find the derivative of p, the derivative of the product. We want to find the derivative of p of x times r of x at x equal to 1. So we use the product rule. We know it's p of x times r of x plus r of x times p of x. We don't actually have formulas for the function, but we are given the value of p at 1, right? It's this column right here. We know the value of p at 1 and r prime at 1 and r at 1 and p prime at 1. You just plug it in and you get the answer. So you can do the same, like for the quotient at x equal to 3, or just some of these other rules. But it's not, we have to use this table, and we can only evaluate the derivatives at 1, 3, and 5. So I think that's all for right now. Don't have students. I really encourage you to do the homework for this section, and we'll just start.